Okay, hello all. Today we want to start talking about something called scatter diagrams or scatter graphs. Okay, so scatter graphs, an example here of one, let me get my pencil to point to it, are diagrams that you use to show a relationship or a link between two pieces of numerical data. So you can only use them for numerical data. In this example here, they're using this table of numerical data. On the top row, the data is the average temperature outside, and on the bottom row, the number of ice creams sold by an ice cream vendor. Okay. One thing to note about these when you're drawing scatter graphs, this is the graph here, the scatter graph. Okay, they have two axes, a horizontal and a vertical axis, but it doesn't matter which piece of data you put on which axis. Okay, they have, in their case, they've taken the average temperature and they've put it on the horizontal, and they've put the number of ice creams sold on the vertical. But it would work just the same, or it would be just as valid if you put the temperature on the vertical and the number of ice creams on the horizontal. Now, however, that said, you would not get the same graph. The graph would look different, but both graphs would be equally correct. Okay. So then I suppose the next thing to say is the reason we draw these graphs is we're looking for a link or a relationship, and that link, we have a special name for it in mathematics. We call it a correlation. So just to look at the word here, a correlation is what we're talking about. So a link between two pieces of numerical data. So for instance, in this case, we want to know, is there a link between the temperature outside and the number of ice creams you might sell? Now, we could probably guess without drawing a graph that the higher the temperature outside, the more ice creams you're going to sell. And that is the case, and that will be revealed by the graph as well, which we'll see in a moment. But before we move on to that, let's just look at how you draw the actual graph. So it's very straightforward. Pick an axis for each of your sets of data, your numerical data. Then, for instance, if we look at the first one, when the temperature was 10 degrees outside, they sold one ice cream. So go across to 10 degrees in the bottom here and go up one then for the number of ice creams sold. Next one is 12.5. It's like plotting points in coordinate geometry, really. So go across 12 for the temperature and up 5. So we're going halfway up the first box there to go up 5 for the number of ice creams sold. So just like plotting points in a coordinate geometry. So back to the correlation again, I suppose, the link. You would expect that there would be a link between the temperature outside and the number of ice creams sold, and that link is that the higher the temperature, the more ice creams are sold. Or another way of saying it, the higher the temperature, the higher the number of ice creams sold. So we have a name for that type of a correlation, or that type of a link, when the bigger one variable gets, the bigger the other variable gets. We call that a positive correlation. Now, there's another way of describing it as well. One way is saying the bigger one thing is, the bigger the other thing is. Another way of describing a positive correlation is the smaller one thing is, the smaller the other variable is. So the smaller the temperature is outside, the smaller the number of ice creams that are sold. Okay? So then I guess that's a positive correlation. The bigger one piece of data is, the bigger the other piece of data is, or the other data variable is. If we wanted to think then about a negative correlation, I'll just bring you over here to a sketch that I did a moment ago. So I'm taking I just made this up, taking two pieces of data here. One is the number of cigarettes smoked daily by a group of people, and the other one is the length of their life, how long they lived for, how many years they lived for. So in this case, you would expect that the more cigarettes that they smoked, the less the length of their life would be, or the longer they lived, the less number of cigarettes they smoked. Okay, and that is the case. If we say that, like, somebody who smoked 0 cigarettes, they should really be living a very long life, shouldn't they? and somebody who was smoking an awful lot of cigarettes would probably live a much shorter life. And so, excuse me, we see in this case, we call that a negative correlation. And a negative correlation is when the bigger one piece of data is, the smaller the other piece of data is. So the bigger the number of cigarettes, the smaller the length of life. Or the bigger the length of life, the smaller the number of cigarettes smoked. Now, one thing to note in this, of course, as you've probably already thought, is that there could be somebody, of course, who smoked a huge number of cigarettes and lived a very long life. And if we were plotting that, I suppose somebody smoked like 100 cigarettes a day or something like that and lived to be 100 years old, and we were plotting it, it would go over here on our graph. And it seems to be kind of far away from the rest of our points, which form a sort of a natural line going in this direction here. And of course that will happen. And we call that type of piece of data, I suppose, an outlier. So it can happen, we know, but it's not the norm. Okay? So let's just look then. We had our positive or negative. So positive correlation is when the bigger one thing is, the bigger the other thing is. And we saw that in our first example here with the ice creams, and we see it's kind of forming a line going up in this direction. Okay. We have a negative correlation here, forming a line going down in this direction. And we saw that it's same in this. We saw that it happens when one data variable is getting bigger, the other one is getting smaller. Okay. And then we have the situation where there's really no link at all between the two variables, and they're not correlated at all. And there's no kind of line structure as we've seen in positive and negative correlation. The points are just all over the place with no pattern. Okay, so that's positive, negative, and no correlation. Now we have an even more defined way of describing correlations, which we'll get into next week. But for now, just positive and negative and no correlation will suit us fine. So one other thing I want to describe then is that correlation, I suppose, shows a link between two pieces of data. In our first example, it was number of ice cream sold and daytime temperature. Now, in this case, we could probably guess, I mean, we'd have to do more investigation, but I think we could all say with a fair degree of certainty that the higher the temperature, the more ice cream sold. It's the higher the temperature causes more ice creams to be sold. So in this case, there's correlation, but there's also what we call causality. In other words, one of these causes the other thing to happen. The high temperature causes people to buy more ice creams. But when it comes to scatter diagrams, when we're doing them normally, just because there's a correlation or a link between two pieces of data does not mean necessarily that one causes the other. So we'd imagine in the other example we talked about as well, where the more cigarettes you smoke, the shorter your life. Again, there would be a causal link there, or there is causality there between the number of cigarettes you smoke and how long you live. But if we take another example, for instance, you can take my word for it, that there is a positive correlation, a graph that looks like this, between the number of churches in a city and the amount of crime in a city. In other words, if there's a positive correlation, it means the more churches there are in a city, the more crime there is in a city. Okay? Now, here's the thing. There is truly a positive correlation there. I'm not making that up. However, there is no causality there. In other words, churches do not cause more crimes to be committed. Okay? So in some cases, there can be correlation without causality. Of course, in the churches and the crime example, there is another missing piece of data that links the two, really, I suppose. And that piece of data is population. In a city, the bigger the population, the more churches there are going to be. But also, the bigger the population, the more crime there's going to be. Okay, so there's a kind of a hidden piece of data there. But if we were to just take number of churches and amount of crime, we would find that there was a positive correlation between the two of them, which means the more churches, there are in a city, the more crime there is in a city. But again, it does not mean that the churches are causing the crime. Whereas in this case, we would say the high temperatures are causing the ice creams to be sold. So sometimes correlation indicates causality, sometimes correlation does not indicate causality.